Today we're going to continue our discussion of basic electronic components with capacitors first. A capacitor is a passive device that stores an electrical charge. How that works, you learn in Physics 2, if I'm not mistaken. But its uses are blocking direct current, which allows alternating current to pass. In that regard, it can act as a filter. Whether you want the alternating current or the direct current, you can use a capacitor to filter out the unwanted signal. Coupled with a inductor, you can make resonant circuits. We'll get to inductors on a later day, but when you couple a capacitor with an inductor, you can make a resonant circuit that creates a frequency determined by the capacitor and the inductor. And because it stores an electrical charge, it is used in memory. To create specifically dynamic random access memory, or DRAM. That's the memory form that is typically rated in the gigabytes realm in your laptop or your cell phone. The RAM is typically dynamic RAM, which consists of a capacitor and a resistor. And I'll show you how that configuration is set up momentarily. But it makes for a very small configuration on a integrated circuit die. You could squeeze a lot of memory into a very small location using just a capacitor and a resistor. All right. So capacitors are characterized by their capacitance. This is measured in farads. Now, a farad is a very large unit, so you typically see it in the form of microfarads or picofarads. A 1 farad capacitor would be so large you would probably have a hard time picking it up. They're just it's just a large unit. So microfarads or picofarads are commonly used in electronic circuitry. Now the symbol for a capacitor, kind of the old version is this version, and the newer version is like this. And the variable the variable capacitor is the symbol on the right. Variable capacitors are typically used in tuning analog systems. For example, an analog radio might use a variable capacitor to change the resonance of the filter that filters out the radio station that you want to listen to. A variable capacitor is easier to construct than a variable inductor, so variable capacitors are more commonly used for that. And, sometimes you'll see on this symbol a plus indicating that it is a polarized capacitor, or what's called an electrolytic capacitor. But more common is the two single bar symbol. Most digital systems nowadays do not use variable capacitors. They use other means of filtering signals and creating resonant frequencies. So variable capacitors are not very common anymore, in new designs at least. If you're into older audio equipment or whatever, you might run into variable capacitors. Now, a few formulas, kind of like the resistor. If you have two capacitors in series, You do not add them together. It is similar in nature to the resistors in parallel formula. And as you might imagine, in parallel, you just add the value of the capacitors together and you get the capacitance of overall capacitance of the capacitors in parallel. One of the ways that capacitors are used are in timing. If you have a circuit that has a resistor and a capacitor, and you have a current going this way, it will initially go toward ground until the or is that, am I getting this backwards? I might be getting this backwards here. This will charge, putting a charge on this will cause the capacitor to charge, and then once it is charged, the circuit will continue flowing this direction. Once if you turn off the current coming in from this direction, the capacitor will discharge and continue producing current on the out for a period of time. The time it takes to charge a capacitor is 5t. T equals RC. The resistance of the resistor times the capacitance of the capacitor will determine how fast the capacitor charges. Yes? No, it's the opposite of resistors. In series, capacitors are 1 over C1 plus 1 over C2, and in parallel, you just add them together. It's reversed from resistors. Think of them as like electronic springs. If you put two springs together in series, the springiness is not added together directly. It is if you have the two springs in parallel. If you remember that from Physics 1. But yeah, those are the right equations. They're just, it's reversed from the resistor equations. But this will hold a charge for that period of time. For a period of time. This is how you can store a value, 1 bit, in a capacitor. Either the charge is low or the charge is high. But you go ahead and charge it to store the bit in memory, and then you turn off the input, turn on the output, and you read the bit from memory. But let's see here. I think that's about it for capacitors. We're going to look at LEDs, or diodes, I should say. Also a passive device. A diode allows current to pass only one direction. Allows current to pass only in one direction. Most of the time, it is used for the rectification of AC signals in power supplies. Rectification. I can't spell that today. Rectification of AC signals in power supplies. Basically, that means converting an AC signal into a DC signal. That is typically done with what's called a bridge rectifier, a configuration of 4 diodes connected in a particular fashion. Power systems or circuit theory should get into how that works and all that sort of thing. But basically, it takes a signal like that and turns it into a signal like this. It brings up the negative levels into the positive and keeps the positive in the positive. And then more signal processing will bring that to an even level. These are what's common in wall blocks for chargers that convert the AC signal from the wall socket to the DC signal that powers your USB device. There are different types of diodes. Silicon, germanium, Zener, and light emitting. Those are the four basic types. What makes them different is with their characterization. There is a 0.7, typically a 0.7 volt drop across the diode on a silicon. There's a 0.3 volt drop across a germanium diode. Different materials have different voltage drop characteristics. A Zener diode has a particular breakdown voltage, very precise typically. Now the breakdown voltage is the voltage at which current will flow the wrong direction in a diode. That typically is quite high on your general rectifier diodes. Zener diodes are used to have a precise level go through them, to go through them. They break down at a very precise level. Light emitting is, well, those are characterized typically by the wavelength of light. Typically in nanometers. LED lights have gotten to be a lot cheaper and more versatile in the past 20 years than previously. So they're more common in light fixtures and the backlight of tablets and laptops and television screens. Even powerful enough to be headlights on cars and stuff now. It used to be incandescent bulbs before then that used typically 3 to 4 times the amount of power. But let's see here. Oh, the symbols for the diode. You have the regular rectifier diode. And you might see SI or GE to indicate silicon or germanium. A Zener diode has this kind of weird line on it instead. And a light emitting has the arrows pointing away from it. Now this is the positive terminal. Oops. The positive terminal. And this is the negative terminal. There is very little resistance going that direction, the direction of the arrow. To connect it the other way is to have it reverse biased. And it will block current flow if connected that way. So an LED connected backwards will not light. A common problem in digital logic when people don't connect their LEDs correctly to the logic circuits, they think it's not functioning right when in fact the LED is reverse biased and will not show any light regardless of the signal that being sent to it. But let's see, what else do I got on? If you do put a diode in backwards, there will be some leakage current. So when reverse biased, small amount of leakage. Electronic components are not perfect. They are not ideal. There is going to be a small amount of leakage current, usually in the micro or milliamp range, or probably microamp more likely. But yeah. I think that should about wrap it up for the day. I will have quizzes to return on Monday. I believe the grades are mostly entered into the computer, but everything will be up to date on Canvas before Monday. Have a good day, all.